We're going to continue on with our new chapter on scale factor and similarity. And this section, we're going to cover what are known as similar triangles. So similar triangles are going to have the same shape but a different size. So again, if you connect it back to when we talked about reducing images or enlarging images, you could imagine taking an image. So if I took this triangle, if I zoomed in, the sides are proportional. If I zoomed out, the sides are still proportional. They're also going to have equal corresponding angles. So the two pictures we have, I'll talk about this as like the little triangle. This one is the big triangle. You're going to notice that there's a little open dot by the A and there's a little open dot by the D. So what that's representing is there's no numerical value, but it's telling us that these two angles would be the same. And then if I look at, let's say, angle C, there's like a little tick mark. It's kind of a little bit bent there, and then F has a little tick mark. So what that means is whatever value angle C has would have to match angle F. So these two angles would be the same. And then we all know this, if you have this little square, that represents a 90-degree angle, and there's a little square with a second triangle. So that means that angle B and angle E would be the same for the angles. So the next thing about similar triangles is they're going to have proportional corresponding sides. So I'll go through what that means. I'm just going to clean this up, make it easier to see. Okay, so you're going to notice it talks about how AB is apparently corresponding to angle DE. So AB just means on the triangle from A to B. So if I imagine this side length, and what it's telling me is AB and DE are connected. So on the second triangle, DE just means from D to E. So what happens, the reason why these are corresponding is you'll notice that both of these sides, so AB and DE, they're both opposite of that one sort of like bent tick mark. Okay, so we say that these are connected. Same idea then with BC. So B to C is right here. If you notice, it's across from that open dot for the angle. Well, on our second triangle, the open dot was here. So that's why we can say that BC is connected to side EF. And then finally, the last one, AC, okay, which was across from our 90-degree angle. Well, on the big triangle, that's connected to what's called the side from D to F. Okay, so those are our corresponding sides. Now, they're proportional, which means if I go over here, so we said that AB was connected to DE, BC was connected to EF, and AC was connected to DF. Okay, so you could go back to the picture, and I've connected it with my colored squiggly lines. Now, proportional means that if I were to clean this up, let's say, for example, I got a 2, so I'm just making that number up. If they are proportional, the corresponding sides, these would also have to clean up to be a 2, and these would also have to be a 2. So as long as these numbers are all the same, they're not going to be 2 all the time, then I can say that these two triangles would be similar. Okay, so it tells you there, if corresponding angles are equal and if sides are proportional, then we can say that triangle ABC, there's this weird notation, something to triangle DEF. So new term for you. This little symbol, you guys know me, I like using symbols. It just means is similar to. Okay, so here's our first example. We want to determine if triangle ABC is similar to triangle EFG. Okay, so I already put in there, well, to determine that, we got to figure out, are the corresponding angles equal? And then are the sides proportional? So what I like to do is just label my triangles. So I'm going to refer to this one as the big triangle. It looks bigger. And then this will be the small one. I can barely fit that. Okay. So what I would probably list is I'm going to check angles first. So with my big triangle, I know that angle A is 90, right? Little square represents that it's a 90-degree angle. I know that angle B is 37. Okay, well then what I need to figure out, angle C, I don't have it written here, but we could figure it out. So angle C, all three angles in a triangle have to add up to 180. So I could subtract off the amounts that I know, and I would find that angle C is 53 degrees. So I could add that in here. Okay, next what I'm going to do is I'm going to look at the small triangle. So I'll look at small, and I'm going to try and connect. So on the big triangle, I had a 90-degree angle. Okay, so that was A. So I'm going to look, is there a 90-degree angle in the small triangle? Well, there is, it's E. So I'm going to say, well, angle E is 90. Then angle B was 37. So there was a 37 in the big triangle. I'm going to try and find that in the small triangle, and I notice it's connected to F. So I can say angle F is 37. Okay, well, here's the thing. If this is matching up and if that's matching up, then our angle G would also have to be the 53. All right, so our corresponding angles equal. Yes, they are. So that looks pretty good. Now, here's the thing, actually. If you're identifying similar triangles, you don't actually have to prove both of these. So I don't have to prove that these are equal and these are proportional. By default, if one is true, then the other one has to. All right, if I wanted to figure out if the sides are proportional, what I'm going to look at is trying to set up something similar to what I had over here. Okay, so, and again, I've called this the big triangle, small triangle. So because I'm setting up a proportion statement of some sort, I'm going to label what's going on top, what's going on the bottom. So I'm going to talk about the big triangle on top. So my lengths from this triangle will be in my numerator, my top, and then my lengths from the small triangle will be in my denominator or my bottom. You can flip these, it doesn't matter, as long as all the ones on top are the same and all the ones on the bottom are the same. So either all three small are on top or all three big are on top. Okay, so let's just start with, I'm going to talk about from A to C first. So I'm going to talk about A to C. I'm going to compare that. So we're going to go C to B. So I'm just going in a clockwise rotation, and then B to A. Okay, well, here's the thing. If this is AC, I'm going to check its opposite of the 37 degrees. Okay, so I'm going to highlight this in yellow. So from the small triangle, I got to figure out, do I use the 4, the 3, the 5, which side? So if this is connected to the 37, I got to find the 37 on my small triangle and realize, okay, well that means it's connected to EG. So here I'm going to fill in. I'm comparing side AC to side EG. Okay, so then the next one, CB. So imagine going from C to B. It's opposite of the 90. So then I'll go to my small triangle, find my 90, which is right here. Well, that means that I can compare CB to side GF. So I'm going to write this down as GF. You can also call it FG. The order doesn't matter. It's still the same line. And then the last one is green. So BA, so going from B to A, that's opposite the 53. And I'm also out of angles anyways. I only have one choice. So on the small triangle, we figured out this was 53. We didn't label it, but this is 53, which means it's connecting to side FE. So then I'll put down here, this connects to FE. Okay, so these sides are connected, these sides are connected, these sides are connected. If it is a similar triangle, when I clean these measurements up, I need to get the same number. Okay, that'll make it proportional. So let's fill in our numbers. So from A to C, that has a value of 9. So I can go 9 over EG was 3, C to B was 15. Okay, we said that connected to GF, so G to F is 5. And then B to A was 12. and that connects F to E, which was 4. Okay, so we have 9/3. We're saying that's supposed to equal 15/5, which is also supposed to equal 12/4. Well, you'll notice, clean this up, you're going to get 3 is equal to 3, which is equal to 3. So because these numbers are all the same, we can say that the sides are actually proportional to each other. So we've proved it 2 different ways. Okay, let's try another one. So same kind of question, determine if triangle ABC is similar to triangle DEF. I've already added, okay, 2 ways to do that. You can prove that corresponding angles are equal, and or you can prove that the sides are proportional. So the hiccup with this question, if you look at our diagram, the only angle we have is the 70 degrees. So I don't know this angle, I don't know this angle, I don't know this one, and I don't know that one. So in terms of trying to use the corresponding angles or equal part, we're going to get stuck. Okay, so I'll just add here. We cannot use it at this point. So this time we're just going to prove whether or not the sides are proportional. So it doesn't matter. To me, I don't know. Maybe I'll call this one kind of looks smaller. So I'll call this one small, this one big. I'm going to put the small on top this time. So small, comparing that to big. Okay, and just pick a point. This time, maybe I'll start with the smallest side. So if I look at the small triangle, I have B to A, okay, which is the shortest side, it's 2.7. So I'm going to go from B to A. Okay, and I know I'm going to have, whoops, I'm going to have 3 that I'm trying to set up here to prove it. Okay, now if I said B to A was the smallest side, it would have to connect to the smallest side on this triangle as well. Because even though I don't know this angle, if this is the smallest side, this would actually have to also be the smallest angle, just as a side note. So if this is 2.7, I'm going to find the smallest side here. Well, to me, that's the 2.5. So I'm going to be comparing this side to that side. So BA, I'm going to compare to ED. Then I'll just keep following. I'll find the next smallest side. So if I look, I have 3. So I'm going to look at side AC, comparing it to on my picture. So be careful, this actually wouldn't be the next side. I'm going to look at E to F. So E to F. And then process of elimination, I only have one side left. I will go C to B and compare it to D to F. Okay, now that's not really helpful right now. We need to fill the numbers in. So let's go back. So B to A was 2.7. So I'm going to say 2.7. Comparing that to E to D, so ED was 2.5. I'll clean up the value after. A to C was 3. E to F was 4. And then C to B was 3.3. And D to F was 4.1. Okay, this time it's not as easy to see. So probably want a calculator. So 2.7 divided by 2.5. So this is going to clean up to give me 1.08. 3/4. Okay, I know that's 0.75. So right away, I can stop. These ones are not the same, so definitely these two triangles cannot be similar. But just to keep everything balanced, I will show the last one. 3.3 divided by 4.1. This ends up being 0.80. Okay, so because these are not the same, we would say sides are not proportional, which means these are not similar triangles. Now, what I recommend, once you have gone through example 1 and example 2, I suggest taking a break and then practicing the following textbook questions first before you keep going. Sorry, my page froze. So I would stop here, practice these questions first, check your solutions in the back of your textbook, and then come back and watch example 3. So example 3, different type of question. This time we want to determine a missing side. Okay, so it tells you that triangle KLM is similar to triangle TUV, and you want to determine the missing side. It's being represented by the letter X. Okay, so right away, by the question telling me that these two are similar, so it says it is similar, by default, then I right away know the corresponding angles are equal, okay, and then the sides are proportional. So I don't need to prove that. All right. Now, what I would suggest whenever you work with triangles, it's a good idea, try to label all the angles if you can. So you'll notice there's a 50 degrees here, there's an 85 degrees here. It's probably worthwhile figuring out what this angle is. So angle K would be 180 minus the 85 minus the 50. Okay, so if you clean this up, you'll find that angle K is 45 degrees. So I'm going to add that in here. And then I'll do the same thing with the second triangle. But here's the trick. If I know that this is 85 and this is 45, and if these triangles are already similar, because the question said they are, I don't really have to calculate this. I could just pull it off the other triangle. So I know that U is going to be 50 there. Okay, and if you didn't trust that, you could go 180 minus 85 minus 45, you would get 50. Okay, so I want to find the missing side, X, and again, I'm going to think about this as being the big triangle, this will be my small triangle, and then in terms of which I'll put on top, so am I going to talk about the big or the small on top? Because I want to find X, I would always make sure it's in the top left-hand corner. So I'm going to start by going big to small. Okay, and then I want to find this, so I'll use green. Okay, so we're looking for this side length. We'll put that in green. Okay, but what I need to do is I have to compare that to the side that it corresponds to with the little triangle. So I'm going to look, well, side X is opposite. So imagine you drew an arrow straight from this angle, you get that side. So it's opposite the 85, which means the corresponding side on the small triangle has to also be opposite 85. So my diagram's going to get messy here, but I'm going to then compare it to this side length, which has a value of 10.5. So I could compare it to 10.5. Now, if you want, you're more than welcome to show, so let me go back up here for a second. You're more than welcome to show this setup first if it's helpful. But sometimes students get a bit confused by that, so I'll start just plugging in the numbers. So I'm saying these two sides are corresponding and they're proportional, so I'm going to go X comparing it to the 10.5. Okay, well, I need to set up a proportion statement. So I need two other sides here. Okay, so it doesn't matter. I'm going to by default take the 50. So I'm going to look at my angle that's 50. I'm going to use its side. So across from the 50, its side is this 21. So I'm going to put 21 here. And then same idea. Well, this is the 50 for the big triangle. Find the 50 for the small. So the 50 for the small is right here. If I were to go directly across from that angle, its corresponding side is the one that has a length of 7. So I'm going to compare that to 7. Okay, good news. When you're trying to solve the missing side, you're only going to use two parts. Go back up here. So you'll only use two parts of this. So you don't have to set up all three. Okay, so I have two parts set up, and hopefully you'll notice this is just a proportion statement. So you have an unknown and you want to solve it, so we can then cross multiply. So I'm going to go top times bottom. Technically, you can go top times bottom. You'll get 7x is equal to 21 times 10.5. You'll get 7x is equal to 220.5. You got to get x by itself, so undo the multiplication by 7. divide this side by 7, divide that side by 7, you're going to find that x would have a length of 31.5. Double check, there's no units, so you can just leave it like that, and you could say that is your final answer. Another option on this question, I won't show this solution, it'll just get too long, but you could have also compared, so the x and the 10.5, you could have used these two side lengths as well, the 24 and the 8, you would end up with the same solution. Okay, moving on to example 4. So another question where we want to determine a missing side. So question says, determine the missing side if triangle GHI is similar to triangle KLM. All right, so reminder, if they are similar, we know the corresponding angles are going to be equal and the corresponding sides are going to be proportional. Now, what you'll notice on this diagram, it's a little different. There are no angle measurements. So we just had the side lengths. Okay, so that's all right. What we are going to assume though, so this time, clearly this is my small triangle. This is big. Because they're not giving us any angles, you shouldn't have to guess which ones are connected, so which ones correspond to each other. So you'll notice that the diagram is kind of set up that it's almost like you took this little one and just like zoomed in to make it bigger. Okay, so what I suggest, if they don't give you the angle measurements, but if you can identify that, okay, it looks like angle G is probably connected to angle K, I would just kind of denote it with a little symbol. So you can use an open dot, closed dot, you could use a happy face, smiley face, 1 tick mark, 2 tick marks, etc. So I'll show that I is connected to M, and then, I don't know, I'll do a little star here for H is connected to L. All right, now we are trying to find X, so I'm going to highlight. I want to find this, so let's start with that, which means I'm going to be comparing this time the small to the big. Okay, so I want to find X. I know I'm going to set up a proportion statement of some sort. So if I look, X is across from the angle I, which I denoted with like the 1 tick mark that's kind of bent. So go to your big triangle. Here's the corresponding angle. Okay, so angle I, angle M are going to be the same. And then I'll look at this side directly across from it is being represented by the 10. So I will fill that in here. Okay, so I'm looking at comparing these two sides. So GH to KL. And then if I look, I could use the 2 and the 8 because they're both opposite the stars, or I could use the 1.9 and the 7.6 because they're both opposite of the closed circle. It doesn't matter. I like the stars, so let's use the stars. So I'm going to compare this side, which is 2, to this side, which is the 8. So I'm going to say 2 over the 8. Okay, so the 2 is opposite of the star, and the 8 is also opposite of the star. Okay, so we now have a proportion statement. We can solve it. So we're going to cross multiply. Now, here's the little trick, right? Is if you have your unknown, okay, on top, you don't have to do the whole cross multiplication. So I kind of talk about, you could actually just do half of it, save yourself a little bit of time. So I'm going to end up going 2 times 10, and then dividing that by 8. So I would get 20 divided by 8. Question didn't state, but let's give a decimal answer. Why do I say that is I noticed these have decimals. So we are going to say x is 2.5. Okay, now if you're not really sure what I did there, I'll just show you again. So we had this x over 10 is equal to 2 over 8. All I did is I skipped, so I went top times bottom, and then instead of having to go top times bottom here, where I would get 8x is equal to 2 times 10, and then you'd have 8x is equal to 20, and then you would have to divide both sides by 8. You still get the same answer. So I just skipped this part where I end up multiplying by 8, but then I divide by 8. Okay, so if you like sort of that little shortcut where you only have to do what I call half the cross multiplication, go ahead. If it makes more sense to always show both sides, perfectly fine. So our answer to number 4 would be 2.5. So again, once you've gone through example 3 and example 4, what I suggest, stop for a bit, look at your textbook, try these 2 questions, check your answers in the back of the book. If you're getting stuck, please fire me an email. I can help you through that. And then come back and then look at example 5. So example 5 tells you determine the length of the lake using similar triangles. Okay, so you guys will notice that you only have this on the page if you're printing off the blank ones or looking at the blank ones. So what I've done is I've imagined it's kind of like the 2 triangles are sort of like part of each other. So what I did is I kind of took this big triangle, so I'll color it in blue, and then just drew it on the side here. I just find it easier to break them apart. Some of you will be able to work with it just as is on the diagram, and that's perfectly fine. And then I took this little one inside, I'll color it in green, okay, and I drew it beside. Because then what happens, once I set these 2 triangles up, it's going to mimic what we had up here, right, where they're already separated. Okay, we've got to do a bit of work though with the sides. So the green is okay. So they're telling me that this is 0.9, it's miles. This is 2.4 miles, and this is 3.0 miles. Okay, so I use this number, use this one, use this one. Then what it's asking you to find is it wants the length. So this is their lake. So I'm trying to find this length here. Now this length, I got to do a bit of math. So it's 1.2 plus the 2.4. So that should be 3.6. Okay, so if I add these two together here, 1.2, 2.4. And then same idea, this long length here from my picture, well, that's like the 1.5 plus the 3.0. So that'll have a length of 4.5 miles. Okay, so I like to take the diagram, split it up, because then, I'm even going to move it over. I can just focus, oh, it moved on me, sorry. I can just focus on the 2 triangles that I have on the left-hand side. All right, now again, I don't have all the angles, but I know that this is 90. Okay, this is also 90. So these sides are connected to each other because they're opposite the same angles. And then the way the picture is set up, okay, we can say that this side, or sorry, this angle would be connected to this angle. Okay, and then also this angle up here would be connected to this angle. Okay, so this time since I have colors, why don't I say I'm going to look at the blue triangle, compare it to the green. The reason I do this is just to remind myself what numbers have to go on top, which are on the bottom. Now I'm trying to solve for missing side. So once I do a few of these, I'll realize that I'm going to be setting up a proportion statement. X is what I'm trying to solve for. So by default, I always try and put that in the top left-hand corner. Okay, it just makes it a bit easier to solve. So I'm going to compare this side here, which you'll notice is opposite of what I'm using as like the 1 tick mark with a little bit of a bend. Go to the green. Well, that's right here. So I can connect that to the 0.9. So I will go x over 0.9. I'm going to drop the units while I do the calculation. And then again, you have 2 choices. You could use the 90-degree angle. You could use the closed dot angles. So I'll use the 90. I'm going to go back here. Across from the 90, it's 4.5. So 4.5 goes on top. Why does it go on top, not the bottom? Because I have the blue triangle measurements on top. So both of these have to come from the blue triangle. Both of these have to come from the green. Okay, so 4.5 was on top. Go to your green triangle. Here's your 90-degree angle. Across from it, the length is 3.0. So I compare it to 3.0. All right, do your cross multiplication. I'm just going to do the shortcut method of just doing half of it. So we would have x is equal to 4.5 times 0.9 over 3.0. Make that bigger, it's multiplication. Okay, so you don't have to show all this, but this is like 4.05 divided by 3.0. Okay, so my calculator will tell me I get 1.35. Now double check, the question did have units, it was miles. And then because it's actually connected to a situation, I would probably try and put a concluding sentence. So you could say the lake has length of 1.35 miles. All right, so again, now I want you to go in your textbook on page 151. There are a couple of, I don't know if I'd call them word problems, I guess so. So there's a couple of word problems that you can try. Just they're connecting the similar triangles to an actual somewhat real life situation. So try those two questions, see how you make out, check your answers, email me if you get stuck. And if you're feeling pretty good about the similar triangles and you want to push yourself a little bit, there are some challenge questions you could try as well. So let me know how it goes and have a wonderful day.